Using media in an Android application is a common task, and nearly every use case shares some common features. The first is the media player. This is the component that can take in digital media and render it as audio or video. The second is the media controller. This is the piece of UI that controls the media player and includes all of your playback buttons, such as the play or pause button, fast forward and rewind, skip to next, or previous. There are many options when it comes to these components, including building them from scratch for your specific needs, but the nature of their interaction is nearly the same for every application. This is why the Android framework provides two classes, a media session and a media controller, that impose a well-defined structure for building a media player application. The media session and media controller communicate with each other so that the UI stays in sync with the player using predefined callbacks that correspond to standard player actions, such as play, pause, stop, etc. You can also include extensible custom calls that you can use to define special behaviors unique to your app. For example, you may want to include a take screenshot button in your video player. We'll go into more detail into these components and their callbacks later on, but for now you can think of it as a standard decoupling pattern. The media session isolates the player from your UI, so you can easily swap in different players without affecting it at all, or change the look and feel without changing the features available in the player. Another major reason for this structure is the following. Media is often controlled by more than one controller. It might be a car, like Android Auto, a watch, Android Wear, headphone media buttons, a notification on your screen, and potentially even other apps. They may need to fade out your audio for a second to deliver important notifications to the user. This is why you should use this client-server architecture. The media session then becomes the server that holds the info about the media and the state of the player, and each controller becomes a client that needs to stay in sync with the media session. Okay, so now we know we need a media session and a media controller. How are these implemented in Android? The answer depends on your use case. Apps that play audio exclusively have slightly different needs than apps that include both video and audio. When playing both audio and video, the UI is expected to remain visible for the duration of the playback, since the user is watching the video, so navigating away from the UI should probably terminate the playback. When playing only audio, however, you will most likely want the playback to continue, even if the user navigates away from the UI, like if they're listening to some music or an audiobook and want to check their Instagram. In this case, the playback continues even when the UI is not visible, as can be seen from this notification. We'll investigate the implementation of a media session and a media controller for these different use cases in the following node.